In this short bit of video, we're going to take a look at a simple model of an MM1 queuing system. On the screen, you'll see that there is a drawing area, a set of objects that we can drop into that area, and the usual menu system, along with a clock that shows us the movement of time. So let's just create a very simple queuing model, an MM1 queue, where we have parts arriving according to an exponential distribution, and the processing also takes place according to an exponential distribution. These are the defaults in this particular tool, FlexSim. So we're going to just connect the parts of the system up together to provide the logical flow, and then we'll test the model. So I'm just doing some basic preparation at the moment. So let's have a look and see what's going on here. Okay, so we see some default graphics, some rather muddy brown coloured boxes moving through the model. Not particularly easy to see, so let's just stop the model and change those for a more obvious colour. So I'm going to go into some triggers, some little bits of code that execute at specified times, and let's just change the colour to the first one on the list, which is a light blue colour, and check to see that that's working. And hey presto, there we go. We've got some light blue boxes arriving in the queue, and if you look closely you'll see that the queue contents are varying. They're not always the same, when of course a simple static analysis would suggest that there is never any queuing taking place. Let's change the means of these two exponential distributions to the ones we used earlier in the classroom exercise. So a 1 minute into arrival time for the source, and 0.98 minutes according to an exponential distribution for the processor or the service, 0.98. And before we run the model, I'm just going to set up some statistics so that we can observe the process over time. Rather than just looking at it as the model runs, we want to capture the data so that we can then analyze it later on. So about ready to go now. Let's click on the run in a second and we'll see our parts arriving, and I've sped up the rate of time advance for the graphics. So the model is executing, but we're only seeing the graphics update irregularly, which is why it seems a little bit jerky, and why parts on the processor sometimes appear to go backwards. It's a bit like watching a bicycle wheel on a piece of movie footage. Sometimes appears to go backwards. Okay, so we've sped it up and we've now done 10,000 minutes of time. So we'll just slow down the rate of graphics refresh, and then we'll have a quick look at the statistics. And we see a trace of the content of that queue over time for the last 10,000, in fact for the last 5,000 minutes of observed time. Now we would expect to see a long-term average for this system of about 48 parts in the queue. You can see there that the maximum content has actually risen to 154, and its minimum content is of course 0. So I'm going to stop the model again and just have another look at those statistics, and let's just wait for me to do that. Okay, so I slowed the graphics down just so you can see that things are actually moving along correctly, and let's now just speed things up again and look at the chart. Okay, so here's the chart, soon to appear, and there we see it carrying on roughly from where we left off before. We're between 10,000 minutes now and 15,000 minutes, and that's the MM1 queuing problem modelled in FlexSim.